Quick reminder guys, check the description for a link to our self-made seminar. It's a 3-day hands-on training event where we are going to teach you how to make a living making videos at home. Hey guys, I'm Nate, welcome back to the lab. Today we've got a very fun experiment where we see what happens if we put liquid propane into liquid nitrogen. Now liquid propane usually will freeze at 306 degrees Fahrenheit below zero. Liquid nitrogen is about 321 degrees Fahrenheit below zero. So it should, in theory, be cold enough to freeze our propane into a solid. I want to see what happens, and I bet you do too. In a previous video, we showed you a little hack for how to get propane out of your canister in a liquid form rather than a gas. We're going to be using that hack to partially fill a water bottle and then lowering that water bottle into our liquid nitrogen to see if we can actually get our propane to solidify. As a part of this experiment, I have this mixture of propane and butane in this can. It's usually used as a camp stove fuel. We're going to try the same thing, putting some of this into a bottle and then freezing it and see what happens, especially if it'll light on fire. Now I don't want to fill the house with the fumes of propane and butane, and I also don't want everything to light on fire in here, so we're going to move this outside. Our first step is going to be to pour off some of our liquid propane into our water bottle. So I'll just turn the nozzle upside down, put it in the bottle, and then open it up as far as it'll go. You can see after a couple seconds of cooling down, it starts just dripping out. Smells very strongly of propane. Oof. Propane usually boils and turns to a gas at about 45 degrees below zero. And that's pretty cold, but it's not nearly as cold as liquid nitrogen. All right, there we go. We can see that we've got liquid propane about to this first line in the water bottle. Kind of hard to see through just because it is pretty cold and a lot of frost starts forming on the outside of it, but you can see how much we've got. So now we've got a very cold liquid in the bottle. Let's take our very cold liquid and put it in an extremely cold liquid. Here goes. I think I can probably just kind of let it sit there. The propane will be dense enough to submerge a little bit into the liquid nitrogen, but the air on top of the propane, of course, is much less dense. So it just sort of holds itself floating with the propane under the liquid nitrogen and the rest of the bottle above it. I can see some vapors forming inside the bottle. I don't know for sure what that is. I assume it's condensed propane, but it could be water condensing on the inside of the bottle as well in the form of water vapor. Well, it's only been a few seconds, but let's check. Nope, still liquid. Let's let it keep going. Water freezes at about 32 degrees Fahrenheit, propane freezing below 300 degrees below zero. So it has to get really, really cold before it starts to solidify. Still liquid. It almost has to get down to the temperature of the liquid nitrogen to help insulate the bottle so it really keeps all of the cold in and to help keep some of our liquid nitrogen from dissipating. I'm just going to take some paper towel and push it in the sides just to maybe save ourselves from losing a little bit of liquid nitrogen. Can't tell for sure, but it does look like there is something going on in there, so I'll pull it out really quickly. Let's look at what's happening. Oh man, I think I ruined it by pulling it out. It started like clouding up a ton in the liquid. It looked like it maybe had a little bit of freezing just starting to go, and I should have just let it go. Definitely see something happening in there. Little bits moving around. I think we're actually getting a little bit of freezing on the surface of the propane. Well, our propane in the bottle has now been sitting in this nitrogen for quite a while, probably at least half an hour. And I think we might have gotten a little bit of a slush, but it's certainly not frozen solid. It's possible I would just need to leave it in for much longer. You know, ice in a freezer takes up to 3 hours to freeze sometimes, so it's possible that I would need to do the same thing with the propane. Because I'm not that patient, I'm gonna try taking it out now and see what happens if I just pour it out. I'm hoping we have a little bit of a slush thing going on. It's hard to tell while it's still in the container. Either way, after I pour it out, I'm gonna light it on fire. Here's our bottle, and that still looks pretty runny. It does look like it's somehow separated, like there's another layer I wonder if liquid oxygen has formed on top of the propane or something. Doesn't really look the right color, but there's more liquid in here than when I started, so it has to have come from somewhere. Let's pour it out and see what happens. Woo! The bottle got too cold. All right. That is a beautifully dense white smoke. And it looks like we've got liquid propane. Very, very cold liquid propane. This may be very dumb. I'm going to try and light it on fire. Maybe not so dumb. Well, it's on fire. The wind is kicking up a little bit, getting more air in there. That's about what I thought would happen. The propane just dissipates so quickly. Oh, and now it's gone. Once you pour it out, it just disappears almost entirely and immediately. Well, that didn't work very well. I was really hoping for some frozen propane, but I'm not sure how long that would take to really get to a solid chunk. So now I'm going to try pouring a little bit of liquid nitrogen into a cup and then pouring some of our propane into the liquid nitrogen with no bottle in the way. Give that a couple seconds to cool down and then it should start dripping. All right, liquid nitrogen, liquid propane. That is about the thickest, densest white smoke I've ever seen come off of here. It's not smoke, vapor. Wow! Definitely was not expecting that. Wow. Okay, something about the propane and the liquid nitrogen made it pop. I don't know what did that. There's just sort of a bubble of propane floating on the surface of the nitrogen. Huh. Lighting it up with a laser, you can see the little propane blob floating on the liquid nitrogen. Man, I am amazed that that is not started to solidify. It is just in liquid nitrogen. It's touching the liquid nitrogen, but it's doing really nothing. And if anyone's curious, no, the laser is not actually affecting the movement. It moves exactly the same way with or without the laser beam on it. It doesn't run away from the laser. It doesn't run to the laser. All right, I do still have the butane and propane mixture, and butane freezes at only 220 degrees Fahrenheit below zero, so it's possible that the mixture will freeze in the liquid nitrogen better than the straight propane did. Let's find out. Man, this nozzle is great. That went way faster than the propane one. Okay, propane butane mixture. Let's lower this down into our liquid nitrogen, which has lowered itself quite a bit down. Used up a fair amount of liquid nitrogen on this experiment. We got some sort of vapor climbing up out of the bottle. Not really sure what that is. Could be condensed air. Could be the propane and butane. While I've been waiting, it's gotten a little colder out here, so you'll notice I'm now wearing a jacket, but I think we've made good progress. Our butane-propane mixture seems to have started to solidify on the inside of our water bottle. I'm not sure if it's a slushy consistency or a solid one. My plan is I'll take the water bottle out, cut it open just above where it's frozen, and then either try and pop it all out if it's solid, and if it's not solid, then I'll try and scoop it out with this popsicle stick. And then either way, I'm gonna light it on fire. There you go. Okay, it's still very easy to squish, so I doubt it's frozen completely solid. Yeah, look at that. It's like propane butane soup. Some kind. That stuff's weird. Oh, it's melting. It's melting. That stuff melted almost instantly. Once that stuff wasn't surrounded by liquid nitrogen anymore, it started melting immediately. That was fast. Whew! That got on my hand just a little bit. Didn't melt the glove. Definitely no injury from it. And now it's gone. Just warmth, really. Startling warmth, not dangerous warmth. to be clear. Our little piece of bottle, I tossed it through the flames and it still had propane and butane residue all over it, so it caught on fire and then just shrunk down. We just have the very bottom of the bottle now. There's actually even still some frozen stuff in there. I don't know if that's propane and butane. I think that might just be ice. I think there was a little bit of water residue inside the bottle because it's not evaporating all that fast or melting as fast as the propane and butane did, so pretty sure that's just ice. There you go. Our experiment was to see if we could freeze propane, and while I think we might have had it get a little bit slushy after sitting in our liquid nitrogen in a bottle for about 30 to 40 minutes, it definitely never got solid, and if it was slushy, it immediately turned back to a liquid after it was poured out. The propane and butane mixture did work considerably better. I think that's because the butane has a higher freezing temperature, so the two mixed, we were able to get a very dense slush. I think it might have even turned solid eventually if we had just left it in for longer. It's also possible though that the butane was freezing and the propane was not, and we wouldn't have really achieved a solid block unless we left it in there for hours, if at all. Either way, once we scooped that thick paste out, it immediately started melting. Soon we just had a puddle of a mixture of butane and propane in our little pot. That was fun to light on fire, but it wasn't really anything spectacular. Overall, I would say that butane and propane are best left in liquid or gaseous form. They're much more useful that way. Freezing them is very difficult, and it doesn't get any sort of flash burning the way that gasoline does when we freeze it in liquid nitrogen. Thanks for joining us for this video today, and remember to come grab some hats, shirts, or other merch at thekingofrandom.com. See you there.
It looks alive, like an amoeba.
The bottom of this pot is extremely cold, and the top is also cold. It's just cold everywhere, even though it was on fire. Oh, this spot's warm. Quick reminder, there is a link down in the description to sign up for our self-made training event. If you've been wanting to build a career from making videos at home, doing the things that you love, this is how you get started.